Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in microprocessor. We're going to see features of 8086 and register organization of 8086 microprocessor in this video. And before starting with 8086 microprocessor, we have seen what is microprocessor, what is microcontroller, what is the basic difference between microprocessor and microcontroller, what is the basic operations of processors in previous videos, right? I would recommend you people to go through those videos first so that you can get the basic idea about the microprocessor and microcontroller so that you can start this video with a clear idea, right? So we'll start with features of 8086. So when it comes to 8086, it is the first 16-bit processor released by Intel during the year 1978. And it is a third generation microprocessor, whereas in first generation, it never supported the TTL, and in second generation, it supported TTL, but it's not at a greater speed. And this is about the third generation microprocessor, where we use HMOS technology, and it is massive, but right now it is manufactured using HMOS 3 technology and contains approximately 29,000 transistors right now, whereas in first generation it never supported the TTL circuits, right? And it is available with 40 pin IC, that is 40 pin dual inline package, and it has 4 different versions of 8086, which is available in 5 megahertz, 8 megahertz, 4 megahertz, and 10 megahertz. Coming to the important features, right, as I said, it is a 16-bit processor where we will have all the registers will be a 16-bit register, and it has 16-bit data bus which can able to read and write in the memory or IO port, right? And we can use either 16-bit or 8-bit. That is a very important feature about 8086. And very importantly, it has 20-bit address bus, whereas it has 16-bit data bus. And regarding address bus, it has 20-bit address bus, so that we can able to have 1 MB of memory location, because 20 MB of address lines, which is 2 to the power of 20, will approximately have 1 MB of memory location, right? And 8086 is not a very highly sophisticated processor, where it is designed basically to perform a fixed arithmetic operation. And later Intel designed a processor, a coprocessor 8087, which can do floating point arithmetic and complex mathematical operation, right? So 8086 can be combined with 8087 to do fixed point, floating point, and other complex mathematical functions, right? And apart from this, a very important concept in 8086 is it supports 2 different modes, which is minimum mode and as well as maximum mode, where while explaining the architecture and pin diagram, I'll explain in detail about pin mode and maximum mode. What is minimum mode? In minimum mode, it will act as a single processor, right? It will act as a single processor, whereas in maximum mode, it will be acting as a coprocessor, whereas it can be integrated with different processor so that it will be working in a multiprocessor environment, right? And in multiprocessor environment, control signals from memory IO are generated by the external bus controller, right? So you have 2 different modes, which is minimum mode and maximum mode. As if now understand that minimum mode, it will work as a single processor environment, and in maximum mode it will act as a coprocessor, which means it works in a multiprocessor environment, right? And apart from it, the power supply which we use is 5-volt power supply, and we have 2 ground pins here in 8086, that is to reduce the minimum power dissipation, right? To reduce the power dissipation to the minimum, we use 2 ground pins here, and it is a 40 pin IC, as I said. And very importantly, it has 6 instruction bytes, that is it can able to it has a 6 instruction queue, where it can able to prefetch the instruction, that is 6-byte instruction can be prefetched, right? And it can be saved in a buffer in that instruction queue, so that the execution can be done one by one. More importantly, this instruction queue helps 8086 to perform pipelining. You know what is pipelining? To speed up the operation of the processor, we go for pipelining. That is, we normally know that there will be a fetch phase and the execution phase, we know that there will be a fetch phase and execution phase. Fetch phase is nothing but fetching the instruction from the memory, and after fetching, the processor what it will do is it will execute that instruction, right? So here in pipelining, what it will do is in the first clock cycle, it will fetch the first instruction, and in the second clock cycle, the first instruction will be entering into the execution mode, and the second instruction will be fetched in the second cycle. That is, more number of operations can be done, right? It reduces the number of clock cycles, right? We have already seen what is pipelining in previous videos. Please go back and refer that, right? So by design, 8086 supports two-line pipelining, and apart from that, the architecture of 8086 is designed in such a way that you have two important units. One is bus interface unit, and another one is execution unit. So what is bus interface unit? It is used to fetch the instruction, right? And also it will interconnect with a lot of system buses, right? And very importantly, it will fetch the instruction and it will save the instruction queue, right? And from bus interface unit, it will send to the execution unit, where execution unit, the complete execution of the instruction will be done in the execution unit, right? So you have bus interface unit and execution unit as the two important blocks in the architecture of 8086, right? So that is about very important features of 8086. And before seeing pin diagram and architecture, you have to be very familiar with this register organization of 8086. As I said, you have 20 address lines. If we say 20 address lines, then it is 2 to the power of 20, so it will be capable of having 1 MB of memory location, right? So this memory is normally split into 4 different segments, right? So that is code segment and stack segment, and then a data segment, and then extra segment. You have 4 different segments. We will explain that in detail in about architecture, but as of now you understand that the memory is split into 4 different segments, and each segment is capable of 16-bit address location, that is 16-bit registers, right? So which means each and every segment can able to access or can able to have around 64 KB of memory location, right? So this is just an outline about the memory about 8086, right? And coming to register organization, the register organization of 8086 is split into 4 different categories. One is general purpose registers, segment registers, and then flag register, and then pointer and index register, right? So general purpose registers, even in 8051 we have seen we have general purpose registers. Normally general purpose registers is used in the temporary storage of data, right, or the instructions, right? And here we have 4 different general purpose registers, which is A, B, C, and D, which we can represent as AX, BX, CX, and DX. All these are 16-bit. Also 16-bit, so we can represent it as AX, BX, CX, and DX, right? And these 16-bit registers can be split into 2, that is AH and AL, that is a higher byte and lower byte, right? Similarly, higher byte and lower byte, higher byte and lower byte. So AH, AL, BH, BL, CH, CL, DH, DL, right? So if you want to use 8-bit data, we can use only the lower part alone, and if you want to use 16-bit data, we can use the complete register, right? Normally this AX is nothing but the accumulator. This AX will be acting as a default 16-bit accumulator, and if it is only 8-bit data, then this AL will be acting as a default accumulator for 8-bit. Similarly, this BX register, we can use it for saving a base address or offset address, right? Whenever we use indirect addressing, right, we can use this register to save a base address or the offset address. Similarly, the C register, CX register, it's a 16-bit register again, right? This can be used as a counter, that is to save the count values for the loop instructions, right? We know what is loop instruction, where an instruction like it will execute it only when a condition gets satisfied. So until then the count keeps on increasing, correct? Right? So we can use this particular C register to save the count values, right? And similarly this D register, which we called as a default destination. What is default destination? Which will be, this register can be used for implicit operations, implicit instructions. That is an implicit instruction. We don't have the operand, right? So this can be used as a default destination. Similarly, if you're going to use any 16-bit multiplication, that is, say for example, if you're going to multiply A16 cross BX16, right? AX16 cross BX16, so it will be producing value of 32-bit, right? Where we can able to save only 16-bit data in any register, right? So 16-bit will be saved in the accumulator, and the remaining 16-bit will be automatically saved in the default destination, which is DX. So DX is nothing but default destination address, right? And segment register is very, very important register. As I said here, right, I said the memory itself completely is segregated into 4 different segments: code segment, and then stack segment, and then data segment, and as well as extra segment. What is code segment is all about? Code segment, like it is a part of a memory where we can able to save the codes, right? And what is stack segment? We know stack is nothing but like for a temporary purpose, right? We will use stack memory, right? And whenever we use push and pop operation, like while going to enter subroutine, we need the stack operation that will be none, right? The address has to be pushed to the stack and then popped again back to the program counter. All those things we have seen in microcontrollers, correct? So this stack segment is another part of the memory, where data segment, where we will be saving the original data, right? And extra segment is a part of a memory where we can able to save the extra data which cannot be saved in this data segment. So that is about code segment, stack segment, data segment, and extra segment. We have registers for all these segments. That is code segment register, and then stack segment register, and data segment register, and extra segment registers. All these are 16-bit registers. All these are 16-bit registers. And we have flag register, right? You already know what is flag register. We will see in depth about flag register in architecture, but flag register is nothing but it will reflect the current status of the ALU. Depending upon the result, the corresponding flags will be enabled: carry flag, parity flag, right, zero flag, and all those flags, right? That is about flag register, right? And very importantly, we have pointer and index register. Pointer and index register. We have source pointer and base pointer, and then source index and destination index. And similarly, we have IP. IP here in 8086 is instruction pointer, which will tell you the next instruction that is going to be executed, right? That is index pointer, right? And what is this? All these things, that is stack pointer, base pointer, and SI and DI, right? I would like to give you a good example here, like 8086, right? It will be capable of determining the physical address. You can able to calculate the physical address. What is physical address? We know that the address line of 8086 is 20, right? And the physical address of 8086, that is, we can able to calculate a physical address at 20 address lines, right? 20 address lines. And similarly, physical address will be of 20 bits, 20-bit physical address for 8086, right? To calculate physical address, we will have segment register. This is the formula: segment register into 10H plus offset pointer. What is offset pointer, right? Now you can see this is the formula to calculate the physical address. I'll just erase everything so that you can understand. Okay, so physical address, the formula, this is the formula for physical address, which is nothing but physical address is equal to segment register into 10H plus offset pointer. So what is offset pointer here? Right? Now you got to understand here, right? There is something called segment address, and as well as offset address, right? And segment address will be located here in segment registers, and offset address will be in the offset pointers, right? These will be acting as a offset pointers, right? I'll explain that. To calculate the physical address, right, we need a physical address of 20 bits, as I said, and this is nothing but stack register. We know that these are the stack registers, and these 4 stack register are 16 bits. All are 16 bits. All are 16 bits, right? And that will be multiplied with this 10H, but we need 20 bit address. So the remaining 4 bit, it will be the offset point. It will be given by the offset pointer, right? So what does it mean for the CS, right? Say for example, if this SR is going to be CS, right, then IP will be the offset pointer for the code segment, right? And similarly, for SS, these two, that is stack pointer and base pointer, will be acting as a offset pointer. Whereas stack pointer, it will represent the first address of the stack, the highest address of the stack. The other address can be accessed by using BP, right? So this two will be acting as offset pointer for SS. Similarly, the SI, source index, can be acting as an offset pointer for DS, and similarly for ES, extra data, DI will be acting as an offset pointer, right? So in order to calculate the physical address, these will be acting as a offset pointers for all this segment registers, right? So I believe you would have got basic information about the register organization and the features about 8086. So in this video, what we have seen is we have seen the important features of 8086 and register organization of 8086. I believe this video will be very useful for you. Thank you, my dear students.
Thank you students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.